Hey geometry students, we're in lesson 12-5 and here we're finding the volume of a pyramid. Now basically this is similar to the prism from the last section. The difference is we have this extra little multiplier out here called 1/3. So the base, the B stands for the base of the figure, and in this case it's going to be a square figure, normally a square pyramid, sometimes a rectangular, but we have then this shape right here. So that's usually going to be something like side, same length here, so our base would be like s squared. And then we'd have a height, and that's going to be from the peak of the pyramid to the base, right to the base. And then we multiply that by 1/3. So 1/3 BH. And it's okay, it can be on a slant as well here. Okay? It's kind of like an oblique pyramid or smushed over. Okay? Based on the Cavalieri theorem or property. So here we go. Let's look at finding the volume, right, of a square pyramid. So when they say square pyramid, they mean the base of it's a square. So in our problem here, we do have a 3x3 square as its base. Okay, so all we're doing is we're doing 1/3 the base times the height, and the base is a square, so we have 1/3, and then our base would be side squared, or 3 times 3, which is 9, and then multiplied by 7. So you can easily see that 3 divides 9 3 times, and then you'll have 3 times 7, which is 21. So 21 inches cubed should be the volume of our pyramid. So we have 1/3 base height. We're letting the base be side squared. We have 1/3 then 3 squared times 7. Or we do have a final answer of 21 cubic inches. Alright, so next problem you're going to try, check your progress. Go ahead and pause your video to find the volume of the pyramid. So good, if you said 138 2/3 cubic feet, that would be correct. So we do have a square pyramid. So again, indicated by here, which is how our problems will be for the most part. So we have 1/3. The base is then 8 times 8. And then that's going to be multiplied by a height of 6.5. So let's go ahead and take 64 and multiply by 6.5, and that gives me 416. And then 416 divided by 3. If we divide that by 3, we do get 138. And we do get, if we use our calculator, we get 0.6 repeating. And 0.6 repeating basically is 2/3. So there you go. 138 2/3 cubic feet. Now what we're going to do is when we're looking at the volume of a cone, which is very similar, except for the base is not going to be a square. So this is kind of, almost we could call this like a circular pyramid. Alright, so we have a volume of a cone. In this case, we have 1/3 base times height, but my base is circular. So instead, we're going to have a pi r squared for the area. And again, it can also be on a slant. So we're going to use 1/3 pi r squared h as the volume of our cone. So here's our example. It's pretty straightforward. We have a cone that has a radius of 12.2 feet and a height of 25. So we're going to use a volume formula of 1/3 pi r squared h. You have two values to plug in. You have a radius and then you have a height, and that's it. It's pretty straightforward. So we have 1/3 pi, or pi over 3, radius squared. So if that was 12 squared, I'd say 144. Let's do 12.2 squared, and then multiply by a height of 25. So we have 12.2 squared, and that gives me 148.684. Multiply it by 25. That gives me 3,721. And then we could multiply that by pi, and then I guess divide by 3. And so multiply my answer by pi, divide by 3, and we're going to get somewhere in the almost 3,900 range. So let's see. So there's the 1/3 pi r squared h. Plug our values in, and somewhere close to 3,900, right? Using our calculator, and then final answer 3,896.6 cubic feet. Now, if we were rounding this to nearest tenth, then we would have said 0.7 because it was 0.6 repeating. Okay, let's find a volume of a cone to the nearest tenth. Okay, new problem. Pretty straightforward, but not exactly. So it looks like they're pointing here to be 5 inches. So I guess that's giving us our radius. Okay, and this 12 inches is pointing to the dashed line, I believe, and so we're going to consider that probably the height. So we're going to say volume equals 1/3 pi r squared h. My r is 5, so it's 25. So we have 25/3 pi, and then multiply by an h of 12. My 12 and my 3 reduced down to a 4, so it looks like I get 100 pi. Now, before we round this to the nearest tenth, we could probably do this without a calculator because pi is approximately 3.14159, and if you multiply something by 100, you're simply moving the decimal point over 2 places. So we're going to say 3, 1, 4. So when we move it over 2 places, it's going to go 1 and then 2. So we have 314.1, but we're going to round it to 0.2. Okay. Let's see what the software does. So there's the 5 squared times 12, 314.2. And it says use a calculator, but obviously we did not. The volume of the cone is approximately 314.2 cubic inches. All right, we're going to check your progress. We're going to find the volume of an oblique cone, but remember the oblique cone, it's okay to be oblique. It's still going to have the same volume. Okay, so go ahead and pause your video and see if you can find the volume of this cone. You said 9,154.4 cubic meters. You got it right. So let's show the work. We have volume equals 1/3 pi r squared h. My r is 20.6. So we have 1/3, or pi over 3, I guess we could say, right? Multiply by 20.6 being squared, multiplied by a height of also 20.6. So I guess we could say pi over 3 times 20.6 to the 3rd power, if you wanted to. So let's take 20.6 in our calculators and raise that to the 3rd power, and then multiply by pi, and then divide by 3, and I get 9,154.408. So round to the nearest tenth would be 0.4. Right. All right, check your progress. You're going to find one more. Go ahead and pause your video. All right, so if you said 1005.3, you got it right. So let's show it. We have 1/3 pi r squared 64 times height 15. I guess we could say the 15 and 3 becomes a 5. And then 64 times 5 is 320. So we get an answer of 320 pi. That'd be an exact answer, but it wants to the nearest tenth. So let's take 320 and multiply by pi in my calculator, and I get 1005.309. So to the nearest tenth, we have 0.3.